Hello everyone, today I want to show you a new dataset that I downloaded from Kaggle website, and the dataset is about the wine information about 1599 wine. I'm going to describe this dataset, visualize some of the variables, go through kind of review of what we learned so far, and then we are going to talk about outliers. Okay, so now I'm going to use the three main packages that I always use. I'm going to copy the path of dataset on my computer, and I'm going to copy paste the website, the link I got this data set from. And then what I'm going to do, I'm going to read CSV, and what we are going to do, first of all, we are going to see what is the shape of this data set, and then another thing, we are going to see what is the columns of this data set. So let's use print function to print the shape, and then we get the first three rows of this data set. So we have 12 columns as you see here, and we have 1599 rows, right? And then these columns are all the characteristic of wine, the level of alcohol, the quality of wine, which is kind of the most interesting. I wanted to concentrate on this as the variable that I'm going to kind of focus on, and keep this as a response variable, dependent variable. Okay, so what we should get from this data set, we should describe this data set. We get the number of observations for each variable, we get the mean, we get the standard deviation, minimum, maximum, and all the quartiles and median, right? And then for each of them we have all this information, and it seems all of them are numerical variables and they are numbers, right? And then I assume that the quality is a numerical variable, even though at first glance you will think that this is a qualitative variable. So let's show you what I mean exactly. So if I write down dataset dot quality dot describe, we can get a specific information that we got for all the data set. We can get that for only the quality, right? And then what else we can do, we can get some specific information about that. We can use unique, which is a kind of method to get the number of groups or some specific information about categorical variable. If I do that, it will show me the ranking are 3, 8, 4, 7, 6, and 5. So they are all ordered from 3 to 8, right? But I want to consider this as a numerical variable. Why? Because I can say the quality of wine, an average is 5.63, right? And I want to say the quality of wine has a unit of measurement, which is point. So let's consider this as a numerical variable. And then what I want to show you, another method that I like, is data dot quality. So you can use this for any of these variables in the dataset, right? Unique, and what else? This one, actually I want to show the size, group by size. So what I'm going to do, I'm going to use group by and then I'm going to choose quality, and this is a method that comes from the pandas, because we are getting this method from the data set. Our data set was created under pandas data frame, right? And then I'm going to say size of this. When we group this quality group by the different kind of values, then we get the size. So what happens in this situation, we will see it's a kind of crosstab. So actually crosstab, okay, so let me correct myself, because crosstab shows the interaction table between two variables, but this one shows specifically the kind of frequency of each of these numbers. For example, the ranking 3 repeated for 10 wine, the ranking 4 for 53, and wow, now you will see the rank 6 and 7, 5, 6 and 7, which are around average. Most of the wines have a ranking around the average. Okay, so in this situation we can group by different values and then find the what is that frequency in for each ranking. Okay, so that's it. These are all the basic information we can get from our data set, right? What else we can get? Let's draw some graph. So we can import Seaborn as SNS, and then we can draw a count plot, SNS dot count plot, which is kind of similar to bar graph, but in our situation that I'm considering this as a numerical variable, I will not call this bar graph because that causes confusion. So we say our data set quality. So I'm getting the quality column from my data set, and I'm going to label them by the counts, and let's see if I can show the plot. Yes, so now we'll see that for ranking 5, 6, 7, 5 and 6 we have the most kind of wines in this data set. Okay, so the other one will be import PyLab as PL, and then I want to divide my data set, not divide actually, I want to get a sub data set, and this sub data set contains all the variable of interest. Let's go up to see. So for example, we can get fixed acidity. So first I should create an array, right? And then the other one, let's say volatile dot acidity, and then another one citric dot acid. I have all the columns name here, and then next one residual dot sugar, and what else? Density, what else? let's say alcohol. Okay, so just keep, I want to keep these. Oh, sorry. And what I plan to do, I want to draw a histogram for all these variables in the data set. So what I want to do, I want to say sub data that I created. Let's create the histogram with how many bins? 30 bins. And I want to create the figure size to be what? 9 and 9 is good. Oh, I don't get error. So let me play run this. What error did I get? It says passing list like to LOC or by missing label is no longer supported. Okay, Panda, why don't you support that? Okay, so let me continue and then we'll think about that. Subtitle, I want to name it histogram, and show. Well, that's very kind of, that's not nice of Pandas. Why? Because I realized this is not even the kind of mistake I had, and this is sorry, this is not correct. This warning is not correct. Why? Because I was reviewing my writing and I realized instead of sugar here I had a mistake. So if I fix that, everything is fine. I don't know why Pandas is saying Jupyter Notebook is saying Pandas doesn't support this. Anyway, okay, so I wanted to show you these histograms. Okay, so we can look at these histograms for 6 of the variables. You will notice that the residual sugar is normally distributed all over this data set, and then we can realize alcohol is has a right skewed distribution. So what this means? It means most of the wine has the alcohol around 0 or let's say 4 to 10, and then so the majority of, I can say, wine has alcohol level between this value to this value. This is the way we explain this graph. So what about this one? This one is the same, right skewed, right? The majority of residual sugar, the majority of wine has a residual sugar around this much. So has a lower residual sugar, right? And what else? This has some outlier here. There's an outlier here. Here for sugar also we will see some of the wine count as outlier. If we zoom in, you will understand there are some of the wine that falls outside of the overall pattern. Okay, so let's continue with some more kind of description. Let's again use Seaborn as SNS, and let's actually we already import Matplotlib, right? So we did that before. It's here. Okay, so I don't need that, right? So what I'm going to do, I'm going to choose some of the columns and call that column's name, and this column's name now, because I don't want to make another typo, so I'm going to bring this here so Jupyter doesn't fool me anymore and doesn't say that Pandas doesn't support or this one doesn't support. Okay, independent equal data set, and then I'm going to choose the column names. So do you see what I do? I created an array, and then I'm choosing those names from my data set by just simply replacing the array I created in here. So it's similar to this one. So I could write down column's name. Let me do that actually. So I'm going to cut this, paste this, and then say columns name, and then I'm going to bring this here rather than creating a huge kind of mess there. So I hope you understand what's going on. Instead of copying the whole thing in here, I just created a variable and bring that variable to here. Okay, so let's continue. I created independent variables and I said, okay, the independent variables are alcohol, pH, fixed acidity, density, quality. I want to just show you a scatter matrix. So it doesn't matter what variables I'm choosing as independent variable now. So the main point is to create a pair plot for all these variables. Did it create that? Okay, good. So this is what you see for the scatter plot I made. And look, for example, quality with density in this row shows this kind of a scatter plot. And obviously it shows a discrete values. So now here on this column I have density, right? And then with fixed acidity, this is obviously a positive slope, and there is a positive association between fixed acidity and density, right? And then here we have the same graph. Why? Because we just changed the dimension. Now fixed acidity is here, density on the row, right? What else? This one. Look, pH and fixed acidity will have a negative slope. Well, that makes sense. As pH increases, the fixed acidity will decrease, right? What else? Okay, here this one and this one are the same. They just have a different kind of row and column. Okay, so what is this one? Alcohol and quality. Well, that's interesting. Well, if I say there is a negative pattern here, I observe a negative pattern. What would I say between quality, between density and alcohol? So as density increases, the alcohol decreases, right? So the only obvious positive slope is between density and acidity. Okay, so what else? Let's do something else. Let's create a correlation matrix. So I'm going to use the method that we already saw. What is that? Pearson. We said Pearson is a parametric correlation method. So what that means we should know the underlying distribution for the variables, for the residual of the variables. So now minimum periods is equal 1. So let's see what we have here. We have a correlation matrix in this way. So what this means, for example, if this one is the column 1 acidity, we will see the correlation of acidity with itself is 1, right? Because these two variables are exact same, right? The correlation is 1. And then correlation between fixed acidity and validate acidity, negative 0.2, which is a negative association and a small correlation, which is closer to 0, means there's a weak correlation between validate acidity, volatile acidity, and the fixed acidity. So the other one, fixed acidity with citric acid, well, almost, I mean, that's not a weak correlation, and it's not a strong correlation. It's 0.67. It's more than 0.5, right? There is some correlation. Let me see if we had citric acid here. No, we didn't. Sugar, there is a positive but very small correlation between fixed acidity and sugar. This is chloride. Okay, it's very small, it's almost 0, right? There's no correlation between, there is, but I mean almost no correlation between these two. And which one is the one we saw? This one, 0.66 between fixed acidity and density. Where's density? Density is here, and this is showing the fixed acidity and density, and as we talked about, this shows a positive correlation, and well, that's stronger than others, right? And then do we have pH here? Yes, pH also says negative, and as we have here, pH is negative 0.68 with fixed acidity. So this pH versus fixed acidity and density versus fixed acidity, they have almost a similar value for amount for correlation, but one is positive, one is negative. So the association between pH and fixed acidity, density and fixed acidity, they are almost similar strengths, but the association is one is negative, another is positive. Okay, I think you can explain this. Well, what I wanted to see, where's the quality here? Quality, is there any association, high association between any of these and quality? What is this one? This one is 0.47. Well, not that bad, but not that good, not that bad. It's moderate. So alcohol means as quality increases, first of all, it's a positive correlation, right? And then second, this is almost kind of weak correlation. But because it's positive correlation, I want to say as quality increases, the level of alcohol, level of alcohol increases, the quality increases, right? You can explain it in that way. Okay, so this is the correlation matrix in table, and then this is the correlation matrix, a scatter matrix, because this is a scatter plot, right? A scatter matrix. Okay, so let's move forward. Okay, so this is the other graph I wanted to show you. This is using pandas plotting, using pandas plotting and a scatter underline matrix as attribute. Okay, so what it's going to do, it's going to get a scatter matrix from the pandas plotting package, right? And then we are going to get correlation matrix from matplotlib matplotlib. We already imported matplotlib, but here I imported matplotlib pyplot, right? Python plot. And here I'm going to just get this package, this attribute CM, which stands for correlation matrix, I think, from matplotlib. So what I'm going to do, I'm going to create a column names. Where's the column names? Where's the column names? Here. And I'm going to, let's see what I want from this. I want pH, I want alcohol, I want fixed acidity and density. I'm not going to have the quality here. This is what we did before. I already know what I'm doing here. Now I'm going to create a dependent variable. And now you know what is the dependent variable here. It's going to be dataset quality, right? We talked about that. This is the response variable that I'm interested in. Okay, so we have independence, we have the dependent variable, and I'm going to create a variable called it CMap. So this is CMap, then it's not correlation matrix. This is CMap. It's a kind of correlation map, probably. CM dot get CMap. So this is the attribute of matplotlib. Well, mplt. That's much better. I don't know why I didn't do that. Oh, actually, sorry about that. This should be CM. I wanted to import that as a okay. So what is that? Okay, so let's get CMap and then GNU plot. That's a kind of method in that get CMap, and then I'm going to create a scatter plot and using a scatter matrix, and then the first argument here is going to be independence, and then I have argument here which is color, and I'm going to color the variables by the dependent variable. So what we are going to see, we are going to see 5 colors, 1, 2, 3, 4, 5, 6 colors, 6 different colors, because I'm separating the whole data set to the colors based on the dependent variable. So dependent variable has like 6 different kind of values, and then the colors also will be 6 different colors. Okay, so there is this attribute marker, and the marker shows the shape of each the shape of each point will be circle. And what I have here, I have figure size. Don't forget to mention the figure size, which is 9 and 9 I'm choosing. And then the CMap, this one is important. We should bring this, what we created using this method, GNU plot, we should bring it here. And let's run this to see what mistake we have, like always. It says dependent. Okay, typos. Okay, so now look at this, how beautiful it is. So it's separating these scatter plots by the color of dependent variable. Let me remove this. So now you will not see those kind of color, but if I add this, it will show color, and this is a kind of helpful argument here of why, because if I want to kind of explain classification later, I'm going to use this attribute to classify the data. Okay, so look at this. I think one time I wanted to talk about this with you, but I forgot. If I change the marker to something like this, we will have triangle. And what else? Do we have anything like funny? A star will show stars, right? And then what else do we have? Well, of course we should have a defined shapes, right? Okay, S shows a square, right? Okay, so these are what you can discover on your own. But typically O is being used. Typically. Okay, so what we have here, we have a correlation matrix, right? And then it says fixed acidity has a positive correlation with density, negative correlation with pH. Well, not that much correlation with alcohol, right? And then the whole data for the fixed acidity is right skewed, means the majority of wine has a lower acidity. And pH is normalized here. It's in a pH data. Means the majority of wine has moderate or average pH. And what else? One of the wine or a couple of wine, few of them actually, can have a very high pH. Okay, so what else in this graph? Okay, we can actually add another attribute, HIST underline KWDS equal to beans, which is like this. And let's say I want to have, colon. Let's say I want to have 20 beans for these histograms here. Let's see what happens. And as you see, the beans are smaller, right? The width of beans are smaller and the number of beans are more. And then what attributes? Oh, this one is nice. So let's change this attribute to this one. And then I want to change the size of markers to 20. Let's see what happens. 20 is very small. So as you see, S is the size of points or markers. Let's say 120. Yes, this is not nice. 20 was much better. What else we have here? And then I can give a subtitle to this graph. I can say a scatter matrix. Has no attribute subtitle. No, that's literally my mistake. So I'm showing this all to you. I'm not going to kind of cut part of this video because you must see this kind of mistakes, and when you have this kind of situation, first of all try to find the typos or any mistake that you have in the writing, and then if you don't find any typo, any mistake in your writing, then start to I would Google it. I would find the best solution on internet, and that will actually lead me to find more information about this kind of packages. Okay, so alpha. We already actually saw alpha, but I like that because that will shade the points for me. So let's bring this up to 70, and then you will see what I'm talking about. So if I decrease this to 0.2, the points are shaded and they are more transparent. So I like this attribute. We already saw this, but as a kind of review, alpha shades the markers or points. Okay, so these are some fancy things you can do on this kind of graph. The other one, last one, promise you this is the last one. I'm going to add this attribute. What was that? Let me see. Diagonal equal k, if I'm right, KDE. Let's see what happens. See, this will shows a density curve on each of these histograms. So density curve is really good because now you will see a right skewed pattern here, a right skewed pattern here, more normal pattern. This one is also normal. So this one shows density curve on diagonal. So by default, these are all histogram. Okay, so now for the end of this video, we are going to create subdata and dataset.loc, and I'm going to bring the columns from here to here. I'm going to say I want to just select this, and I want to use box plot. Because box plot is one of the good visualization tool to detect an outlier. So we are going to plot this, and what's the kind of plot? Box plot, right? And then subplots true, and we want to give it a layout. And let's say how many I have. 1, 2, 3, 4. Let's create 3 rows and 2 columns like this, or we can create 3 columns and 2 rows. Okay, so that's fine. And share x equal false. You should go back and see what this does. We already talked about this. And share y equal false. Okay, now it's going to be better. And then so we have share x, share y. So I think we talked about share y on vertical kind of distance between the what's that, y-axis, and this is similar to this one. Figure size, let's say 9, 9. Okay, so this is much better, right? And then let's give it a title. Title is equal to box plot to detect outliers. Okay, so and the points you see here and here, very above the maximum and minimum on each side, because you know this box plot shows the middle part is median on the x-axis. For example, for alcohol, median is almost 10 point something. This third quartile is 11 almost. The first quartile is almost 9.5, and the minimum something around maybe 8. And the maximum is this much. And then what are those points? Those points that are above the maximum are the outlier. So this is a boundary, maximum, minimum. And what we can actually talk about is, I think we can make this horizontally or vertically. I will let you find that, how to convert this to horizontal box plot, because I think we already talked about that. Okay, so what happens in the simplest way of detecting outlier is finding the first and the third quartile in the data set. And we create interquartile range that we call that IQR, and IQR is Q3 minus Q1. And then when we use this measure 1.5 multiply IQR, we'll get a constant value, and this value is very important to detect an outlier. So 1.5 is a constant value that helps us to detect outlier. 1.5 multiply IQR. This will be a number, right? And then what we do with this number plus Q3 will give us a boundary, upper boundary. This number minus Q1 give us a lower boundary. So imagine with this number plus Q3 and minus Q1, we are going to make a lower and boundary for each of these variables, the data in these variables. And then if any of these points exceed this boundary or it's outside of the boundary, then we are dealing with an outlier. Okay, so for example, for alcohol, let's go back and see what was the information of alcohol we got. So for alcohol, where is alcohol? This one. So we have all this information. 10.42 is, let's bring that here. Dot alcohol describe. Okay, so now we are looking at the data properly. So the Q1 is equal to this much. Q3 is equal to this much, right? And then IQR is equal to Q3 minus Q1. And then I'm going to print IQR. And then IQR is 1.59.9. And then I'm going to print 1.5 multiply IQR, and this value is 2.395. So I'm going to call this IQR 1.5. Oops. IQR measure. For outlier. So I'm going to copy this here, and then I'm going to say Q3 plus this number. And then I'm going to print this. And call this upper boundary, and then I'm going to create a lower boundary, and this time Q1 minus this one. Let's see. Okay, the one point 5 multiply IQR. Okay, so now the upper boundary is 13.5, the lower boundary is 7.10, right? So the minimum value we have is 8.4. So this one is way lower than 8.4. In another word, no value is passing the lower boundary. No value is lower than the lower boundary, right? Then now look at the upper boundary. Is there any value in our data set for alcohol which is above 13.5? Yes, there are some value probably, because the maximum value we have is 14.9, right? And then we have some values like this which are passing 13.5, right? Okay, so here alcohol is 13.5, which is the kind of boundary we have, and there are some value that are above this boundary, above this kind of boundary that we created. So these are going to be those values that exceed our boundary, and they are outliers. Okay, so what else I want to make this nice. This is IQR or interquartile range. Okay, so this is the way we detect outlier in our data set for alcohol. In this just one particular variable, we can see there are some outlier on the right side of the data set. Why do I say right side? Because if I arrange this from minimum to the maximum, like a histogram, this side of data set will be on right side for me. If I make this a kind of horizontal box plot. Okay, so participation point for this lecture is to give me the argument that creates this as a horizontal, like a horizontal box plot, and also explain to me what share Y and what share X does. Okay, we'll see you in the next lecture.